Hello everyone, welcome back to chemistry class. In today's class, we'll study about Bohr's model. Before that, quick recap of models that we have studied earlier. First model was Thomson model. That was plum pudding model or a watermelon model, where Thomson said the charges, positive charges, is distributed all over and in between them scattered one is your negative charges. After that, Rutherford, he performed gold foil scattering experiment and he saw that whatever data he was getting was exactly opposite of what Thomson model was. Instead of having that plum pudding model, he suggested a new model. In that model, positive charge was supposed to be at the center of the atom, that is known as nucleus. And electrons, they are revolving around that nucleus. Now you know there are three subatomic particles, electron, proton and one more, that is neutron. Neutron is discovered by J.J. Proton is discovered by E. Goldstein and electron is discovered by J.J. Thomson. This neutron is neutral particle but massive one. Electrons, they have negligible mass as compared to protons and neutrons. These protons and neutrons, they reside inside the nucleus, that is center part of the atom, and electrons, they revolve around the nucleus. This is what given by Rutherford model. One of the drawbacks of Rutherford model was he was not able to explain why this electron which was revolving around the nucleus, if they are revolving, that means they are accelerating, that means they should radiate energy. So after a certain time they should lose their whole energy, they should fall into the atom. But such thing doesn't happen. So he was not able to explain this thing. Then Bohr, he gave one model and two main points that he gave in that model was, first was only discrete levels are allowed for electrons. That means what Rutherford said? Rutherford said in center you have nucleus and all electrons are revolving around this. Bohr said no, it is not like that. All electrons are not in one orbit. They are at different levels. They are in different orbits. So if this is your nucleus, then these are your different levels, and electrons are in this level, discrete level. That means they are in different levels. And each level has its own capacity to fill electrons. It is fixed one. It is not like that this can have 10 electrons, this can have 4, this can have 18. No, this number is also fixed. Okay. And the electrons which are revolving around, they do not radiate energy. They are in their minimum energy state. That is the minimum energy they can hold. Now because it is minimum energy, so there is no more energy to radiate. So electrons, they are in the atom. Electrons, they exist in different levels, not in one level, and they do not radiate energy. Now let's see this little bit about electron distribution in the system and the Bohr model, pictorial representation of this Bohr model. So if you see here, this is the model given by Niels Bohr. In the center part, red part, if you see, it is nucleus. And this red part, it contains protons and neutrons. The whole of the mass, because protons and neutrons, they are massive and they contain most of the mass, the whole of the mass is concentrated in the center, in the nucleus. Okay. And electrons, they are in different orbits. The innermost one orbit is known as K shell. So these different orbits, this round path that you are seeing, they are different shells. So this is your first shell, second shell, third, fourth, like that. So n equal to 1 means this is first shell. Name given was K shell. The innermost shell is known as K shell. Then you have n equal to 2. Second shell, the name of that is L shell. Then third one, where you have this is third shell, name is M, then N and so on. Now, each shell is having some capability. Now the rule of filling this electron, how electrons are going to fill in this orbit, this is decided by this number 2n square, where n is your number of orbits. Let's start with K shell. So K shell, your n number is, this is your first shell. So n is 1. So number of electron is 2 into 1 square. That is 2. That means in the innermost orbit only 2 electrons can exist. So here if you see, I have made 2 electrons. Similarly, if we see for L shell. So for L shell again, your n is 2. So 2 into 2 square. So that will give you 8. This is 4, 4 to the 8. So 8 electrons can exist in L shell. So I have made 8 electrons. Similarly for M shell, if you find it out, for M shell, n is 3. So 2 into 3 square. That means 18. So 18 can exist in this. So here you have 2 electrons, here 8, 18, for n equal to 4 it is 32 and so. But after filling like this, outermost orbit, maximum electron it can accommodate is 8. These are the rules that are followed by this atom to fill its different orbits. And these electrons, they are revolving around, but they are not radiating energy. Radiating energy means they are not giving out energy. When any charged particle, when it moves with very fast speed, it emits out some type of wave. That is known as radiating. Okay. Here, 2 electrons, they are revolving around. Electrons are charged particles, and this rule is only for charged particles. Here, electrons are revolving around, but they are not radiating because they are already in their minimum state, or we can say in the ground state, most stable state. They don't have any energy to lose, any more energy, extra energy to lose. They are in their lowest energy state. So this is the model given by Bohr, by Niels Bohr. In the center you have nucleus, and then K shell, L shell, M shell, N shell. In the next class, we will study about, we'll take first 20 elements of periodic table, and then we'll try to draw this electron distribution system for those elements. For example, we'll take hydrogen. In hydrogen, there is no neutron. There is only 1 electron and 1 proton. So how we are going to draw shell diagram or electron distribution diagram of hydrogen? Like that, we will try to do it for first 20 elements of periodic table. So with this, please go through first 20 elements of periodic table also. Thank you.